Hello.
Hello.
This is the 0995 CBE 3 review. I'm Caroline.
I'm Megan.
Nice. Hi. Cool. Let's see. Okay, we're just gonna go over the types of questions you're gonna see on the CBE. Okay. Have you already taken it?
No.
No? Okay. Perfect. Okay. So these are the topics that we're going to cover: rational expressions, multiplying and dividing rational expressions, adding and subtracting them, radical expressions, and then simplifying radical expressions. Sorry, rational and radical. I can't read, but okay. Anyway, okay, we're going to go rational expressions first. Okay. Rational expressions deal with the ratio between expressions. That is, so hold on, let me set this to a pen. Rational expressions look like where we have a function on the top and a function on the bottom, where we have some sort of equation on the top and we have some sort of equation on the bottom. And we're gonna just be simplifying and them as best that we can by canceling things out. Okay, here's the first question. Sorry, did you have any questions about rational expressions before we start doing it?
No.
Okay. Okay. Here we have a rational expression. The first thing I see is that both the terms on the top have a 9 in them. And so I'm going to pull out a 9 from both expressions on the top. Okay, so this gives me 9 negative x plus y. So if I multiply that 9 back in, it still gives me negative 9x plus 9y. And then I have x minus y on the bottom. Okay. So I need my signs to be different in the top in order to cancel anything out. So I'm going to also pull a negative out of every term in the top. So I'm going to go negative 9 and then x minus y divided by x minus y, and then those two terms cancel each other out, and I'm left with negative 9.
Right, so this one is very similar. So we first want to see if there's anything we can pull out of the top. So as I'm looking at this, I notice that both of these terms have an m in them. So I'm going to pull out an m. That leaves me with 6m squared plus 1. So the reason it's plus 1 and not plus 0 is because when we're pulling stuff out, we're almost dividing each term by the m. So m divided by m is 1, not 0. Then at the bottom, we just have our m. So now the top has an m and the bottom has an m. So those divide to 1. We're left with 6m squared plus 1. Any questions on that one? So when we multiply rational expressions, so kind of what we were just doing, they multiply just like fractions. So just to remind you what fractions look like, if we're doing this, we just multiply straight across. So we get 2 over 6. So it's the same thing. They look a lot messier, but you're still doing the same thing. So you multiply across, and then you can see if you can simplify. So like this one, you can simplify that to 1/3. And dividing is the same as dividing fractions. So if we had like 1/2 divided by 1/3, to do this one, we learned to do 1/2. So keep this first one and then multiply by the reciprocal, or flip the second one. And then you can just go straight across them. Any questions on that?
Okay, let's go through this one. Okay, so I'm going to first just start. Let's try multiplying. Well, first, let's see. I'm going to pull an 8 out of that first equation on the top because I don't really want to deal with multiplying 80 times 6. So I'm gonna go 8x plus 10 over 16, and then times 6 over 30x. Okay, already I'm seeing that I can simplify these before we multiply across. I can simplify this 8 and this 16. And I can also multiply this 6 over 30. Okay, so this 8 over 16 simplifies down into 1/2 x plus 10 on the top. That looks a lot nicer than before. And then this 6 simplifies down into 1/5 with an x on the bottom. Okay, that makes sense. Okay, perfect. Okay, now I'm gonna multiply straight across. So now I'm gonna do x plus 10 times 1, which is still x plus 10. And then I have 2 times 5x. And so I'm gonna multiply the constant parts together. So 10x. Perfect.
Okay.
I have a question on the last one.
Yeah.
So say like, when you simplified the 8 over 16, what if you got like not a 1 on the top?
Oh, so say this came out to like 3/2 x plus 10 on the top instead.
And
Okay.
then also on the other one, not a 1.
Not a 1. Okay, so and this like say this one also came out to like 4/3.
Yeah.
Okay. Okay, so for this, I'm going to multiply this 3 times 4. So I would do 12 x plus 10. So I'm going to multiply just the constant parts that I can. And then on the bottom, this would turn into 2 times 3. So this would be 6x. And then we could simplify those numbers in those constants in front down from there.
Okay, but you wouldn't need to like FOIL the 12 back into the.
Well, yes, we can do that. And does the CBE ask that you FOIL the stuff back in?
I think on some questions, like it asks you to like multiply it back out.
Oh, okay, so we can multiply that back out. So this would 12 times x and this 12 times 10. So this would be 12x plus 120 over 6x. But you also, I mean, there's more simplification you could do. So you could, in this step here, we could, 12 divided by 6 is 2. So we could like simplify that down more before we FOIL it back out.
Okay, yeah, that makes sense.
Okay, now we're gonna do a little harder one.
Okay, yeah, this one is a big mess. So I'm gonna rewrite this as a multiplication problem. So multiplication is just easier to think about than division. So we keep the first one the same. And sorry, my iPad handwriting is not good. And then you do times and then flip the second one. Oh, we don't need those parentheses, but. Okay, so now from here, I'm just gonna factor everything to see if anything can cancel. So this top one, I'll do it up here. So I notice I can pull a 5 out of everything. And then we're left with that. And now this, we want to find something, so this kind of has a coefficient of 1. So 1 times 6 is 6. So we want to find something that multiplies to 6 and adds to 5. It's 3 and 2. So that leaves us with 5. Because this is a 1, we can just go directly into this form. X plus 2. If you rewrote it like this and then factored by grouping, that's totally fine. That will also work. It'll just give you the same thing. So now the top looks like this. And now I'm gonna factor this bottom part. So this one, I can also pull a 5 out. Okay. And multiplying is just, you can put them all in the top together. And this x plus 4 doesn't simplify, doesn't factor. Now this one, we want something that multiplies to -6 and adds to 1. So we can do 3 and -2, because when you add those, you get 1. When you multiply them, you get -6. So I'll show the long way on this one. So we can do x squared minus 2x plus 3x minus 6. So these still, like this and this, have the same value. We didn't change the value. We just broke up this x into these two. So now we can factor by grouping. So out of this first one, we can pull out an x. We're left with x minus 2 plus 3. We can pull out x minus 2. Then we can combine those to get x minus 2 times x plus 3.
So what's the point of the long way if you can just like use the two numbers that you got from the -6?
Yeah, good question. So yeah, this would still work. So the reason why you do the long way is if this coefficient on the x isn't 1. So if we had something like 3x squared plus x minus 6 or something like that, because then you'd have to like multiply to -18. And then, yeah, so if the coefficient is 1, you can just shortcut to this. Okay, so just gonna draw a line to kind of clean up. So here's what we're left with after factoring everything. So now we want to see if there's anything in common with the top and bottom. I'm seeing that these 5s can divide to 1. Then this x plus 3 can divide to 1. That's it. So I'm always really tempted to take this like x plus 2 and x minus 2 and cancel those because they're really similar. They're like really close to being the same. But even if you like multiply 1 by a negative, then you're left with like negative x plus 2, which still isn't the same. So we can't make those the same, even though we want to. And there's our final answer. Okay, that was a really long one. Any questions?
I don't think so.
Okay. Yeah, that's the same, even though you can't really see it.
Okay. Now we're gonna go over adding and subtracting rational expressions. So before we had talked about how in multiplying, you can just multiply straight across on the top and the bottom. But with adding and subtracting, the same as fractions, times, I'm trying to think of numbers that aren't 1, because that's not very helpful. Okay, here, when we want to add them, we have to make the bottom the same denominator. So I could multiply this side by 3 and multiply this side by 5. So I'd multiply, but in order to keep it the same, I need to multiply by 5 over 5. Because 5 over 5 or 2 over 2 or anything over the same thing is just equal to 1. So if I'm multiplying by 5 over 5, I'm technically keeping it the same. So I'm not changing the actual expression at all. So if I multiply this side by 3 over 3, multiply this side by 5 over 5. So I'm multiplying both by 1. So it's still the same original equation, just changing the numbers a little bit. Okay, so this one on the left here would turn into 10 over 15, 5 times 2, and then 5 times 3. And then plus this other one, this is 12 over 15. And now I can add the top, so now this is 22 over 15, and then keep the denominators the same. Okay. And it's the same thing with subtraction. We would just have to get the same denominators, then we can just subtract the numerators across. Okay. Let's do this one. We're going to factor out a negative out of this part over here. So this bottom term, 1 minus x, is equal to negative 1 plus x. Okay, now that's looking a lot, this inside part is looking a lot more similar to this part, this side over here. So if I rewrite this, 3 over x minus 1, now I have this negative in front and this positive, so I'm going to turn this into a negative.
I'll ask after.
Okay, and then I have this inside portion still, which is on the numerator. So I have x minus 1. So now I have the same denominator. So I can just subtract straight across with the numerator. So 3 minus 1 is 2 over x minus 1. Do you have any questions about that one?
So on this one, it's kind of hard to see from this denominator, like what the factors are. So I'm first gonna factor it, so then we can see what it has. So we wanna find something that multiplies to 40 and adds to negative 13. So I think negative 5 and negative 8. Yeah, that works. Okay, so then we have 1 over x minus 5, x minus 8. So if it helps you think of it better to do it the long way and factor by grouping, you can totally do that. That will work. So then you have this. So now we want to get the same thing. So noticing they both have the x minus 8, so I don't need to worry about that. But this one has the x minus 5 and this one doesn't. So I'm going to give this one of those. So because I did it on bottom, I have to do it on top to keep the value the same. Because then I'm just multiplying by 1 and it doesn't change the value. So then that gives me 1 over x minus 5, x minus 8, minus, and we have 8 times x minus 5. And now the denominators are the same. So now we can just subtract straight across. Oh, I'm actually gonna multiply this out first. So yeah, I'm just gonna do a negative 8. So then I can add instead of subtract. But if you want to just remember to subtract both terms, that works too. So we have negative 8x plus 5. So here we have 1 minus 8x plus 5 over the denominator. That should be our final answer. So,
Hello.
and it also says leave the denominator in factored form, and that's what this is. Okay, any questions on that one? Oh, 41. Oh, I didn't multiply this by 5. Okay, so negative 8 times negative 5 is not 5. It's 40. So it should be 40, then 40 plus 1 is 41. There we go. Okay. Any questions on that? Okay, so next we're going to talk about radical expressions. So when it says radical expressions, it just means stuff like that with like square roots and stuff. So we could have square roots, cube roots, or any kind of roots. So like when we're doing a root, like a cube root is the same as the 1/3 exponent. So the way I like to remember it is like, if you have like a tree, the roots are at the bottom. So if we have like 4 to the 2/3, the roots are at the bottom. And then that's just a way I like to remember it, because I would always forget which one is the root and which one is the exponent. So these two are equivalent. So that's kind of what this is saying. You can take the B and put it out and leave the A. And you can also do them in either order. So kind of like multiplication and division, you can do them in whatever order you want. You could do, in this case, you could do 4 squared and then take the cube root, or you could do the cube root of 4 and then square it. It doesn't matter what order you do them in. So usually, depending on the problem, you do one first over the other just to make it simpler, but both work. Okay. So this is just telling you the square root of AB is the same as square root of A times square root of B. So like if we have square root of 2x, that would be the same as square root of 2 times square root of x. This one is not the same though. If you have like square root of 2 plus x, that's not the same as square root of 2 plus square root of x. So perfect squares, or perfect cubes, perfect fourth roots, that just means that it will result in a whole number. So like that would be 2, 3, 3. So they're just whole numbers, not decimals, is all that that's saying. So you can also usually simplify things, even if it isn't perfect, by like pulling things out. So like we have like square root of 20, we can factor that to 4 and 5. 4 breaks up into 2 and 2. You can pull the 2's out. So this is a simpler version of that, even though 20 isn't a perfect square. 20 isn't a perfect root. Okay. Any questions on those? Okay. I'll do that makes sense.
Okay. All right, let's rewrite this one in the form that we just talked about. Okay, so we have this bottom, which is our root. So we're going to do this negative. Oh, also, this power is only on the 1,000, 10,000. So we're going to keep the negative all the way on the outside, and we're going to ignore that until the end. But we're going to continue writing it. Okay, so we have this 4 on the bottom here, and then 10,000. And then we have that to the power of 3. Oh, another thing is this is also the exact same as if you had 10,000 to the power of 4, and then you put that inside. Oh wait, sorry. That should be a 3. Sorry, this should be a 3. Okay, this to the power of 3. So it doesn't matter if like one is inside of the other or on the outside. Those are both the same thing. Okay, so let's do the 4th root of 10,000 first. I was trying to think of what could be the 4th root of 10,000, and I was thinking about maybe tens, because we do 10 times 10, that's 100. So this is 100 times another 10, which is 1,000, times another 10, which is 10,000. So we could break this up into like 10 times 1,000, and then so we could just do the same thing that I just did, but with the tree. 10 times 100, 10 times 10, and these are all tens. Here's 10 and here's 10. So this is going to end up being negative 10 within here to the power of 3. Okay, any questions about how I did that? Okay, now we just have negative 10 to, oh, it already showed the solution. That's okay. Now we just have 10 to the power of 3, and so negative 10 times 10 times 10. And that's going to be 1,000. And then now we have the negative, so now it's going to be negative 1,000. Okay. Any other any question?
Why didn't you break down the tens into like the 2 times?
I definitely could have broken them down. You can, but I just saw that I had, because we can pull things out when we have pairs. And so if I would have broken this down into 2 and 5, and then again into 2 and 5, I have a pair of 2s and a pair of 5s, so I could pull both those out. That's the same thing as 10 times 10, because 2 times 5 is 10. Yeah, so I just saw that I already had a pair, and so I just left them as that. So because I knew I could pull both of them out. Okay. Okay.
So now this one is pretty similar, but just a little more complicated. So this one is a cube root. So we're looking for things in groups of 3. So starting with this, I'm going to factor it to 32 and 10. And we can break that up into 16 and 2, and then 8 and 2. And 8 breaks up 2, 2, 2. We're getting a lot of 2s here. Okay, so now everything's in their prime factors. So now I'm looking for groups of 3. So I have 3 2s here and 3 2s here. This 5, it's all lonely. It doesn't have any friends, so it just stays in there because we need 3 of something to pull it out. So we can take out the 2, then under the cube root, we still have the 5. Now with these x's, we have 11 of them. So if we were to break this up into 3s, we could write out all the x's and circle in 3s, but that would take a long time. But if that helps you to think of it, you can totally do that. So if we take this, I'm just going to break it up. So we have 3 x's there, 3 x's there, 3 x's, and 2 x's. Like if we multiplied all those, you'd do 3 plus 3 plus 3 plus 2, which gives us back to 11. So now we have 3 of those. So then we can have the x to the 3rd out here, and x squared in here. Okay. Now the y to the 16th, we can do kind of the same thing. So 16 can break into fifths. So this, you're kind of doing like, in your head, you can think of it as division, but with like a remainder. So I know that like 15, I can divide by 3, 5 to get 5. So I have 3x to the fifths, and then there's 1 left over. So, oh, these are supposed to be y's. There we go. So y to the 5th, and then we have a y left over. And then I can simplify this by multiplying those 2's together. To get that. Any questions on that one? Great. Yep, we did it right.
All right, let's do some more factor trees for this one. Okay, let's do this one first. This can be split up into, well, it's even, so I know I can at least do it 2. And can you think of off the top of your head what half of 162 is?
81.
Oh, 81. Okay, Slay. 81. Okay, and now I can split 81 into 9 times 9. I can split the 9s into 3 times 3. 3 times 3. Okay, so now I have two groups here. So I'm gonna pull this 3 and 3 out of the square root and leave the 2 inside. Okay, and then I also have this 18. Let's do this one. So this we can do into 2 and 9. And I have this breaks up into 3 and 3, and that's a pair. So I can pull that out. And then the 2's by itself on the inside. Okay, so now I have 9 square roots of 2 minus 3 square roots of 2. Okay, and so I am just going to subtract the coefficient in the front of it. So I'm going to do 9 minus 3. So that's going to give me 6 square roots of 2. Yay. Okay. Any questions about that one? Okay. Dang, sorry, I didn't realize you were like getting all the harder ones.
No, it's all good. Okay, so this is one where you can use FOIL to remember how to multiply things. So we do the first. So that's gives us 12x. So I'm gonna do this over here because this is probably the most confusing part of these problems. So 4 times 3 is 12. It's the square root of x times square root of x. That's a little confusing. So this we can rewrite as square root of x squared, right? Because this is a root 2 to the second power. Those operations kind of cancel each other. So that leaves us with just x. Does that kind of make sense why we get rid of those?
Yes. I think so.
Okay,
I'm just more confused on the. But never mind. I answered my own question.
okay, perfect. So then we did the first, then we can do the outside ones. Get negative 4 root x inside negative 9, 18. We cannot do multiplication today, apparently. Root x, and then last, negative 6 times negative 1 is positive 6. Now we can combine like terms. So this one's, it's the only x. And these ones are root x. So negative 4 root x minus 18 root x, we can combine to get negative 22 root x and plus 6. Are there any questions on that one? So,
Okay, if you need more help, we have the tutoring center right there. And also there's a bunch of stuff on the website as well. There's the link to the website. And your recitation rooms officers are in there too. Is Megan your recitation room? Oh, okay. But anyway, so if you need more help before it comes up, definitely reach out and come and see us in here. But yeah, that's the end of our CBE review. Do you have any like specific questions about problems that you were struggling with on CBE that we can like work on a whiteboard or anything?
I don't think so.
Okay, well, good luck on this CBE.
Thank you. Thanks for your guys' help.
Yeah.